Hello everyone, I am Prajwal and today we are going to look at this problem string merging. This problem is rated as easy on CodeChef and we require the basic use of DP to solve this. So guys, if you haven't read the problem yet, go back and read it and then come back and see the solution. With this, let us begin. In this problem, we are given two strings, string A of length n and string B of length m. Now we have to merge these two strings into a new string C. The length of this string C should be n plus m, such that every character in C should either be from A or from B. The other thing is that the relative order of characters in A should be same in C. It should also be for B. That is, the relative order of characters present in B should be present same in C. For example, let us say that A is equal to AB. Then in C, A should always occur before B. And if let's say B is equal to C, A, D, then C should always occur before A and D, and this A should occur between C and D, and D should occur after C and A. This means that there can be any number of characters between these, but the relative ordering should be same. So one of the way to merge these two is we can take A, then we can take C, then we can take this B, A and D. So as we can see that A and B belongs to this A and C, A and D belongs to this B. The relative ordering is same. Now we have to find the minimum value of f of C. Now for a string S, f of S is defined as 1 plus the number of valid indices I such that S of I is not equal to S of I plus 1. For example, let us take a string A. In this case, the value of f of S just equals 1. Why? Because we have no occurrences of I such that S of I is not equal to S of I plus 1. All these characters are same. This can actually be seen as the minimum number of blocks that we have such that the consecutive characters are identical. In this, we have only one block. All the characters in this block is identical, hence f of S is 1. Now another example is A, B, C, A. In this case, this is equal to f of S equals 1, 2, 3. So it is equal to 4. 1 plus the number of valid indices I such that S of I is not equal to S of I plus 1. So in this case, we have this S of I is not equal to S of I plus 1 here, and we will add 1 as given over here. So f of S equals 4. This can also be seen as the number of blocks such that the characters are same. So we have this block, then we have this B block, then we have 1 C and 1 A. So overall we have 4 blocks, so f of S is 4. We can take another complex example as AB. Now in this case, f of S is equal to all the single characters because they form one block of size 1. So overall we have f of S equals 6. So now we have to print the minimum value of this C, which will be formed after merging A and B. In the constraints, we are given test cases from 1 to 100. The length can be from 1 to 5000, and it is given that the strings will contain only lowercase English letters. Now let us look at the test case. In the first test case, we are given A as A, B, and B as B, A. Now we can merge these two strings such that the relative ordering is same. So we can write C as, we will take this first A, then we will take this B, and we will take this B now. Now we will take this A and this A. So we will get 2 A's. Now we will take this B and this B, and finally we will take this last A. So as you can see that the relative ordering from the characters in A and B is same in C, and the number of blocks that we will get is 1, 2, 3, 4 and 5. So the answer is 5. Also, the number of valid indices such that the consecutive characters are different are this is different, this is different, this is different, and this is different. So it is equal to 1 plus 4 equals 5. F of C equals 5 as given in the output. Now our problem is that we are given two strings A and B of length n and m, and we need to merge these two into a string C of length n plus m such that the value of fc is minimized. So now one of the observation here to note is that let us say that A is given to us as A1, A2 till A of n, where AI is the character, and B is given to us as B1, B2 till B of m. Now let us say that C is C1, C2 till C of n plus m. So now we can observe that when we are taking some A of I, then all the characters before that should already be taken into this C. This is because if it is not, then when we take a character that is coming afterwards in A and there is some character that has not been taken yet into C, then the relative ordering will not remain the same. These two elements will actually get swapped. So we can observe that we will actually form this string C by taking some prefix of A, then we will take some prefix of B, and then we will continue this into same fashion. So this C1 will actually be equal to A1 or B1, and then C2 will be equal to either A2 B1 or B2 A1 depending upon the character C1. This means that we need to take some prefix values from A and B and attach them to and append them to C to get minimum FC. So now one of the approaches that you might think of is that we can use a recursive approach and check and try to form all possible C's and take the minimum value of FC. So for every point we have two choices, whether we will take the first character from A or the first character from B. The time complexity will be order of 2 to the power n plus m. Now n plus m ranges from 1 to 5000, hence this will give you TLE. Also, you might try to come up with some greedy approach to do this, however, it will not work. There are no obvious greedy heuristics that offer a proof such that we can get a C that minimizes FC. So, since this is an optimization problem, one of the main approaches that comes to mind is dynamic programming, and we will use this to solve. So now, to implement a DP approach, we need to define DP variables such that the states of the DP are identified uniquely. To do this, let us define DP of I, J, and K as our answer, the minimum value of this function such that we have merged prefix I, prefix of length I from A, prefix of length J from B, and the last character that we take is from K. Now this means that K can be either 0 or 1. So if K equals 0, then this implies that the last character was from A. And if K equals 1, then this implies that the last character was from B. So we have defined DP of ijk as the answer, which is the minimum value of this function such that we have taken some prefix of length I from A, some prefix of length J from B. Note that this can be merged in any order. We could have taken A1, then B1, then A2, A3, then B2, and so on. Overall, we have taken prefix of length I and prefix of length J from A and B, and the last character that we put into this string C is from K, and if K is 0, then this means A, else it means B. So now we have our base case. So now we will first initialize dp of ijk to infinity, and then we will define our base cases for the first character, which is equal to dp of 1, 0, 0, meaning we take prefix of length 1 from A, 0 from B and the last character is from A. This is equal to dp of 0, 1, 1. The last character is from B and the prefix of length 1 is taken from B. These both are equal to 1. Also, for all I equals 2 to M, we can say that dp of I 0, 0. That means that the prefix in C is actually taken everything from A. This is equal to dp of I minus 1, 0, 0. And we will add 1 if we have to start a new block. For example, if this was the case, then over here till here we will have only dp of I minus 1, 0, 0. But let us say that the next character is B. Since there is an index such that A is not equal to B, we have to add 1 because we are going to start a new block. So we can write this as A of I not equal to A of I minus 1. We have to do the exact same thing for B. So for all I from 2 to M, we can write dp of 0, I, 1 equals dp of 0, I minus 1, 1 plus B of I not equal to B of I minus 1. The logic is same as the above. Now we have our transitions. So now let us say that we are computing our answer for some I comma j. So we can write dp of I j 0, which means that the current character that we are going to take is from prefix of length I, that is from string A. So this is equal to the minimum of the last character that we can take can be from A. So this is equal to dp of I minus 1 j 0. And if we are taking the last character from A, we need to check whether the current character is equal to A or not. If it is not, then we have to add 1. So this can simply be written as A of I not equal to A of I minus 1. If they are not same, which means that we have to start a new block, hence we will add 1. Also, the last character can be taken from string B. This can be represented as dp of I minus 1 j 1 plus, and now we need to check whether the current character, which is A of I, is not equal to B of j, because the last character was B of j. Similarly, we will write it for dp of I j 1. This is equal to minimum of dp of I j minus 1 0. This means that the last character is taken from string A, and similarly we will check whether the last character, which is A of I, is not equal to B of j, which is the current character, and the last character can be taken from B as well. So dp of I j minus 1 1 plus B of j not equal to B of j minus 1, meaning the current character is not equal to the previous character. So these are our transitions. Finally, we can write our answer as the minimum of dp of n m 0 or the minimum of dp of n m 1, meaning that the last character can either be from string A or string B, and we are taking the whole strings of length n and m respectively from A and B. Now the time taken to compute each state is order of 1, because we need to take the minimum of these two values. So the number of states that we have are n cross m cross 2. So we can write our time complexity as order of n into m. Similarly, we can write our space complexity as the size of this dp table, which is order of n into m. Moving on to the code. So first I have created this array dp. Now I have processed the input, and this is the base case. and these are our transitions. The base case and transitions are exactly the same as discussed before. Also, I have used this extra condition whether I is equal to 1 or j is equal to 1 or not. This is a special case because let us say that if we are taking the first character from A or first character from B, then in that case we don't need to check whether the last character was from the same string or not, because we are going to take the first character. The transitions defined here are exactly the same as before. Finally, we will print the minimum value of dp of nm0 and dp of nm1. So guys, this is pretty much the whole code. Try to code it yourself, and if you face an issue, then come back and see it again. Also, one of the important thing to note here is that I have used an array. So guys, if you are using vector, then actually the problem with vector is that when you declare a vector of size something, then the compiler will actually iterate over the vector and initialize the values to 0. This will actually give you TLE. So use this array. When you create an array, the compiler does not actually iterate over this array. It just gives this amount of memory, and this is time efficient. So prefer to use arrays for this case. So guys, I hope you understood the problem clearly. If you have any questions, drop a comment in the comment section, like the video, and don't forget to subscribe to get our latest updates from CodeChef. Thank you and goodbye.